So is it fabric? Is it some other word? Again, I don't want to get caught up in the nomenclature. What we are coming from is being a very good ADC vendor. What we realize is that we can't simply continue to be a very good ADC vendor. That the market is changing, the market for ADC itself is limited, and our customers are pushing us to move way ahead of, okay, I need a reverse proxy for a website. That's a surprisingly small number of our customers these days. So one of the things we've done in creating this idea of a fabric is we've said, okay, the ADC is a component of that. The LoadMaster is a very good ADC. We're very proud of that product. And Kurt mentioned the ubiquity, the fact that our configuration of a LoadMaster in Azure Stack is the exact same as our bare metal. We call them our gold box. We sell gold box regular 2U servers with a gold front on them. So our hardware configuration parameter screen is the same configuration parameter screen in every other virtual flavor of it. Now, my background is very much cloud. So a lot of what I'll be talking about will be slightly biased towards cloud and virtual as opposed to bare metal and hardware. But KEMP 360 Central was born about 2 years ago, a little over 2 years ago, because we were running into the managed sprawl issue. As Kurt mentioned, you used to have 2 big boxes in a rack, and that was all of your ADC. At Dell, I had 4 big, giant F5s, and every server I had sat behind those. God help me when they went down, but that was it. Well, that doesn't work for that scenario anymore. We now have customers that are going into Azure, going into AWS, going into private cloud, and either those big racked boxes aren't available, or if they are, they're at such a high premium, such a high cost, that they can't operate there. Yes, sir?
Yeah, just wanted to comment on your big box comment, which I totally agree with. The reason we are having those big boxes is because everyone wants to license us on boxes and not on bandwidth consumed. I would love to have a different box for every application, or even better, virtual appliance for every application, but that's ridiculously expensive. So what is your licensing model in this area?
We have a whole section. We have a whole section on what we believe is an evolutionary licensing model to address that. So, to your point, we said, okay, let's go from 2 big boxes to 10 little boxes. But wait a minute, that's 10 perpetual licenses, and what if I need 11? And what if I'm a retailer? If I buy 15, I'm oversubscribed for every month except November and December. So then we said, okay, well, that was a partial solution, and now we're going to move on. And when we get to Mila, which is a section after this, we will talk about getting away from this idea of caring about instances. And I think you'll be interested in what we have to say there. But
okay, is this, you have this now, or we are not there yet?
Oh, no. Everything we have is live. Everything we show you is live.
Okay.
Now, I have one aspirational slide. I do. Because I'm a guy that's very much into deployment automation. Mm-hmm. And we're not as far along in deployment automation as we would like to be. So I have one slightly aspirational slide, but when we talk about our licensing models, when we talk about our platform ubiquity, when we talk about our monitoring and our monitoring of third-party products, our control platform and our control platform of third-party products, that's all live today. We're not marketing guys. So KEMP 360 Central, this is the marketing slide. It's what we wanted to do with KEMP 360 Central. We wanted to be able to manage our ADCs at least. We wanted to be able to visualize, to have that, I know you hate this, but single pane of glass view of the ADC environment. We wanted to bring licensing down to a centralized point. And we wanted to be able to begin to do some analytics. Big data. Everybody loves to talk about big data. So that's the marketing slide of 360 Central. What it really is a virtual appliance that knows how to monitor and control ADCs. Now in this picture, I've purposely only put KEMP ADCs there because what I wanted to show again was, here I have a pointer, is physical, virtual, and cloud. KEMP 360 Central doesn't understand or doesn't care about the difference in those things. So KEMP 360 Central is our control plane and our monitoring plane for Loadmasters. We have since expanded that to say, well, none of our customers, or very few of our customers, especially in the enterprise space, are exclusively KEMP. So we're sitting next to physical F5s, virtual F5s, Barracudas, all kinds of things. And we can't ignore those if we want to talk fabric, because they're part of the customer's delivery fabric. So what we've done is tried to create a picture of what we think what we think a customer needs from us to deliver applications. And we're going to talk about several of these boxes. So obviously platforms, I've listed a bit more of a comprehensive list of the platforms. Mila is the licensing model we're going to talk about. I'm about to do a demonstration of our monitoring and management platform. That's KEMP 360 Central. We've assumed you all know what an ADC is. We're not here to talk ADC. And we're going to talk a little bit about automation. Again, the things I've highlighted here in green we think are things that are leading the market. Maybe not revolutionary, but certainly the leading edge of evolutionary. So in KEMP 360 Central, this is by no means a comprehensive list of what we do, but these are the features I'm going to show you. And if you think I'm skipping one during the demonstration, I'm not. There's going to be a separate demonstration of something we call VS Motion. So the 360 I show you next, I'm going to talk about what the monitoring plane looks like, what the control plane looks like, and what the product is basically doing in terms of not only KEMP ADCs, but third-party ADCs. Then we'll take a bit of a transition, and we'll talk about something that I've worked very hard on with the development organization, and that is this idea of VS Motion. So basically, what does this look like architecturally? KEMP 360, as I said, is a virtual appliance. You can run it in-house, you can run it in the cloud, you can run it in Azure Stack. It then has the ability to communicate, now let's go back first, has the ability to communicate with Loadmasters and third-party ADCs, which are themselves then dealing with the real servers, the applications. If you noticed on my slide, what does it take to deliver applications? Everything was on there except applications. We're not an application company. We're never going to store data in a database for you. We're never going to give you a reply button on an email. That's not what we're good at. So when we talk about delivering applications, we're really talking about from this point outward. What we are good at is understanding applications. We have templates for virtually every off-the-shelf software product that's major in the marketplace. You have Exchange, just tell me what year. You have Link or Skype for Business, just tell me what version. And we will give you a template to create the virtual services to deploy that application. The key takeaway here is that as we expanded from an in-house estate or a colo into the cloud, nothing changed here. It's the same KEMP 360. I didn't need another one. I don't need an agent. It's the same KEMP 360 Central that is managing all of the ADCs wherever they are in the world. And what I'd like to do now is show you that. I'll take a brief, any good Twitter questions come in? No?
Yeah.
All right. This is KEMP 360 Central. And this is actually the newest part of KEMP 360 Central. This is our dashboard. You can see that we're not yet very mature in dashboard technology. I can't move the widgets around. I can't make one widget bigger than the other. I don't have a lot of configurability. But this is only 6 months worth of work on dashboard. What I do have is, again, this idea of single pane of glass. 92% of my ADCs are up and running. I have a couple of ADCs where I might have concerns about licensing. I have some expirations coming up. KEMP 360 Central is a syslog receiver. So all my ADCs are sending their syslogs to 360 Centrals. They can also be sending them to Alien Vault or any other commercial product. But I'm a syslog receiver for the ADCs. And you can see I've had 5K critical. And we'll see what the other breakdowns are. You can see, again, here's the health of my application. My virtual services, 90% are up. My real servers, 85% are up. I've purposely, for this demo, so the graph wouldn't be empty, disabled one of my virtual services and 3 of my real services. So this is administrative disabling, just saying those aren't working and I want to make sure I know about that. This is just a little dynamic top 3. These are the top 3 ADCs consuming resources today. We treat WAF very seriously. We treat ESP very seriously. So we also report them very seriously. I have enabled one WAF virtual service, and you can see I've attacked it a few times today so that you can see the WAF reporting as well. And I'll attack it again in a moment. And then this is a snapshot box. It updates every 5 seconds. At the time that this snapshot was taken, I had 3,371 aggregated connections. That is across all the ADCs that I'm monitoring. I had a low of 0, so for some of my ADCs, I'm not sending them any synthetic traffic. I had an average number of connections and a high. So obviously, I'm pounding the heck out of one of my ADCs. That's really all we can do on this screen today. As I said, dashboard was not the first priority of the product. We came to dashboard when we had customers saying, what you've given us in the other component, if I can find my mouse, what you've given us in the other component was not meaningful enough, not single pane of glass enough. But this was the first, this is the top level page, and the important components here are the network tree and then what happens here in the data area. So the network tree is made up first off of a container simply called all networks. Everything goes below that container. For the purposes of today, I've created 3 networks and named them appropriately to be development, QA, and production. And in a minute, I'm going to open those up and show you what it looks like. But when I'm at the network level, you can see I have a view of my health of the networks, a view of the subnets, a view of my ADCs. Oh, look, third-party ADCs. I have a view of my virtual services and the real servers, and again, a display of the WAF attack statistics. So as we move down the tree, the view changes. When we go, let's go down to production. When we go to a subnet, you can see we've lost, obviously, the global view. We now have the health of this subnet, its devices, real servers, and fortunately, production is where I have my WAF. So, oh, maybe it isn't. And again, there's my administratively disabled, red is down, green is good, and again, my 3 third parties sitting there. Now, as I open below that, I've created I've created just a single subnet under this Azure ARM. So I'm calling that my production environment. And again, if I select down at that layer, I've again lost a little bit of information in that I'm now a subnet. So if there were multiple subnets under production, it would have had more information. Now I'm a single subnet. What this is saying is that below this is nothing but ADCs. And there they are. So these are the ADCs that have been added in. You can see that we have an F5, an Nginx, and an HA proxy. A little bit later, I'll show you an ALB and an ELB in AWS. They're internals. Right now, we are working very, very closely with Microsoft. Today, the Microsoft ILB does not have a real-time statistics API. As soon as it does, we will be able to add the ILB in as well. It's very important to note that we don't feel we compete with the internal load balancers of the public clouds. And in fact, we're desperately dependent upon them. Our HA pair philosophy in hardware and virtual relies on a shared IP address, an IP address that can be shifted between the active and passive members of the cluster. Clouds, of course, are not there yet. And so what we do to provide HA in Azure and AWS is we put our HA pair behind the vendor's L4 load balancer. And so at no point do we ever feel that we compete with ELB, ALB, or ILB. So as we move down to, let's pick.
Have you thought about, for example, like in an Amazon cloud, you could move like an elastic IP address instead of having to use like an ELB in front of your ADCs?
Yes, but then we get into a point where we're now beginning to code specifically to a platform. And except for boot and initial deployment, we try not to do that. So when you boot in AWS, you run Cloud Init. Mm-hmm. When you boot in Azure, you run WA Agent. We have no choice. It's the only way we can boot. But once we've then arrived at a booted VM, a VLM, we call it, a virtual load master, we like that to be the same. We've been told under certain non-disclosure by certain clouds that they are moving towards a SIP deployment. Remember that cloud networks are basically SDN. And so providing a SIP is something that is possible within the infrastructure. It's just not something they've done. If you look at Azure, how they've matured over the last year, 6 months ago, you could only have one NIC.
Yeah.
You could only have one PIP, public IP. Now all of a sudden you can have as many ARMs, NICs as you want. Each of those NICs can have a public IP, and each of those NICs can have multiple private IPs. So we've seen great growth in terms of what the clouds are realizing they need to deliver back for customer satisfaction. So I don't think you'll see us try to say, well, over here it's an elastic IP, over here it's a different type of purchased IP, over here it's not even an IP, it's a NAT rule, and trying to move that around between servers. No, I don't think we'll go there. I think we'll rely on the L4s as we do today, the vendor provided L4s as we do today, and see where that leaves us.
Yeah, also the things we do today where a single IP shifts from here to there, it's wrong, honestly. It's messy, it doesn't scale, but we had to do it because whatever, people can't spell DNS. And it's much cleaner if they sit behind a vendor provided solution and they appear as two IPs and life is good. You do two simple things instead of agglutinating that into one complex spaghetti mess.
And what he calls spaghetti mess, we call technical debt. And what we're trying to do is keep the technical debt of our product very small, because performance in hardware is, ooh, I can buy a faster chip. I can put more RAM in. Performance in the virtual model is, well, I bought a standard underbar A3 instance, and I need it to do as much as it can for what I bought it to do, which was not figuring out how to move IP addresses. It was delivering my website, please. So our commitment is we'll do what we need to do to deliver our availability solutions. But we will not encumber ourselves with technical debt that, as you can see, the room is probably divided. Some agree that moving a SIP is wrong. Others say, oh, no, it's easy to do. And so we don't want to get into the religion of that. So kicking on, this is, again, now we're looking at an individual device, so you can see now we've lost all aspect of what is the network health and the things that were up here before. Now we see specifically that this has two virtual services, one on 443 and one on 80. They're both up. We have three real servers, one of which is down. And again, the WAF statistics being reported. So this is kind of the first view of the product. This is the first thing we delivered. And then we said, okay, that's interesting. Oh, and by the way, we're also, remember I was showing you the top three. We're also eliciting from those devices that we can the system statistics. Now, I do want to say, before I go to you, I want to say one thing about our commitment to third party. We're very committed to third party. We already support 5 different ADCs besides our own. But there are weaknesses in the APIs. The Loadmaster interface, whether it be we call it a WUI instead of a GUI, our web user interface, our PowerShell interface, our RESTful API, all of those things are based on the RESTful API. There's no direct code into the Loadmaster to configure virtual server persistence. It's all done through our API. Therefore, anything we want to do to a Loadmaster or anything that we want to ask a Loadmaster can be done with the API. This is not the philosophy of most of the other third-party ADC vendors. So we are seeing the richness of the APIs increase. The F5 API, the new release, it has double the number of calls it had before. The HA proxy API has 3 calls. So there's not a lot we can do with that today. What we will commit to is continuing to view and study the APIs released by the third parties and integrating as much of that functionality into our fabric as we can. So again, oh, sorry, you had a question.
Our previous discussion got me thinking. So you have 2 different IP addresses in the cloud, behind the vendor.
The two ADCs?
Yes.
Yes.
Do you still treat them as HA pairs? So do they have synced configuration?
Yes.
Okay, thank you.
And today we still treat them as active-passive.
That's interesting. Why would you do that?
Because that was the model we were born with.
Okay, fair.
Being the cloud guy, although being a minority within KEMP, I'm pressing very hard for the active-active. However, Kurt is going to show you later our clustering solution, which is not necessarily HA. It's certainly not a pair. It's an N plus N cluster. But having come from the cloud world, having run a very large logistics operation for Dell EMEA, partially in the cloud, there's no way I'm going to pay for a server I'm not using. There's just no way. Mm-hmm. But we have legacy. We came from active-passive. We're pretty proud of the fact that we're in so many clouds, but we haven't had time to step back and say, cloud doesn't appreciate active-passive. So anyway, the next place we're going to go is what can we do in terms of monitoring these things. And I'm hoping I'm driving traffic to this ADC, because if I'm not, I'm going to be annoyed. We having a network problem? Well, let me tell you of our philosophy about monitoring while we wait for the screen to paint. Again, this is based on API calls, right? We poll the ADCs. And whatever an ADC can give us, we accept and try to graph. Now, it turns out some ADCs are better than us. When I go up to the ELB, you'll find the ELB is sending me latency information and 500, number of 500 requests. Well, Loadmaster doesn't do that today. Now, the guys are scrambling to, but we thought that the three most important things to understand is how much actual traffic is coming in and out, how much of that is SSL traffic, and how many actual connections per second. And you can see that these are time correlated. And again, we're getting better at graphing. A future release will have a single graph onto which you can drag parameters for time correlation. But at least visually, I can see that these spikes make sense and these dips make sense. And so I can get some visual correlation here. These graphs exist all the way up to the top level. So we roll everything upwards. And so an aggregated view is, there's what my environment is doing. If I only care about production, then I can come down to here. Oops. Down to here, and only see the roll-up of all of production. So again, single pane of glass, standoff monitoring. As I mentioned, we take whatever data we can get. And so if we come here and look at, I'm sorry, I'm just at such a crooked angle I can't see where I am. AWS, there we are. If we look at the ELB, you can see that the top level graph has changed. Now we're looking at the number of 500 errors. Do I have any 400s? No. Oh yeah, back there. And connections. Then my SSL and connections per second. So this is a slightly different graph because they didn't agree with us ahead of time what statistics to provide. So whatever we get from the API, we try to graph. If we come down here and look at the F5, you can see that the F5 looks exactly like a Loadmaster. It's giving us all the information we want. If we look at an HA proxy, well, we don't get as much information from them. We graph what we get, but they don't provide this type of information in the API environment.
Isn't HA proxy open source?
Yes.
Yeah.
So you can add this.
Not my job. You want to do it and let us know about it? Great. That's not our job.
Not my job.
What again, the takeaway is what we can get, we will work with. So the same is true. That's kind of the main end of graphing. The next thing is service configuration. And this is going to get interesting. I'll stay on the Nginx for a minute and try to click this. And it's going to say, well, you can't do that. Service configuration involves pushing information. HA proxy isn't fond of that. So today, for certain third parties, we can't provide that. Where we do provide it, of course, is our own devices today. So here in service configuration, I now have the ability to do a limited set of configuration features. We will continue to expand that set of features over time. And so I can come in here and delete it, which I won't. I can come in here and edit, which I will, and show you that this is a virtual service. Now, any of you that's ever used an ADC or configured an ADC knows that that's probably less than 5% of the configurable parameters of a virtual service. However, it is the 95th percentile of the parameters commonly used. If you need to do more than this, you can go to the ADC itself, obviously. But if you just quickly want to make a change to these common parameters, you can do it and push it from here. The same is true for the real servers. Sitting behind this virtual. Sorry, sitting behind it. Here you can see I only have, I think, one real server. But this is our idea of what we want to get to, and that is, if we can make this robust enough, why do we even need you to go to the ADC itself? If you look at the AVI model is a headless load balancer. Everything is done from a control plane. Now, they've run into some disadvantages with that model that we're hopefully going to learn from and not make the same mistake. But our goal is to get this to a point of not just a single pane of glass, but a single source of truth. That this is the place you go to do things to your ADC fabric. Now, all right, I just found an enhancement request. That shouldn't scroll off the screen. Now, before I move on from here, I want you to see how this behaves as we come up the tree. So again, at an individual device, I see just that device. As I move up the tree, I see more and more of the devices that are available. But again, you can see third-party devices or devices where my license has expired offer significantly less capability than those where I'm fully able to communicate and it's a fully licensed product. Now, before we go to the last place, I'm going to come down here to repository. Remember, I told you we're a syslog receiver. We do not intend to replace the syslog management in the enterprise. That's not what this is about. This is for the ADC manager who may not care about what the syslog of the switch is or what the syslog of non-application devices are, to be able to come to a single place and know that everything he searches is going to have come from an ADC. There will be no additional log entries in here. So if he has an ADC-focused problem and he believes that he can find it in the syslogs, he can come here. So if I go in, we've just put, this is pretty standard, the search bar area. So I put in CPU, and now I've found all of the syslog entries from all of the ADCs that have agreed to send me syslogs that have the word CPU in them. I can reset that and say, well, no, actually, what I'd like to know is only messages that are in the emergency to error category. Search that, and now you'll see I'll get a different result. Again, across all ADCs, I will get this filtered only for the messages that meet this criteria. And the criteria is descending, so I can say, well, okay, I'll leave that set, and now I really only care about this device. And do a search. And now I'm only going to get error and above for that device. And again, you can see we've isolated the device IP. So again, just a place of convenience to manage syslogs that are absolutely contained within the ADC fabric. Now, the other part of repository is just a place where we store stuff. And one of the things we store is patches to our software. So here you can see, under firmware, I have a bunch of different patches for a bunch of different platforms preloaded. In a minute, we'll see how I can exercise that. The other thing we store is templates. So I've uploaded just a random sampling of the templates that KEMP offers. We have literally hundreds of templates. But you can see I have Exchange and several other templates here. And again, in a moment, I'll show you how we can take advantage of that. The other thing is backups. So I haven't been very good at doing backups, but you can see that I've backed up some of my load masters, and they are now stored centrally here. That means not only can I recover that specific device, but I can take one of these backups and recover it to another device. So this is what the repository is all about. Where the repository comes into play is here under System Configure. Here, under System Configuration. So remember, service configuration was VSs and RSs. System configuration is actual appliances and devices. So here, what I now have is the ability to, network level. So again, if I choose reboot, it will show me all of the devices that it knows how to reboot. Again, I can't ask an HA proxy to reboot. And would then allow me to select those and either issue an immediate reboot or set a schedule, or select them individually. And again, as with reboot, I have template push. So you can see I can select a template and a device, well, not that device, and a device, and I can push that template to that device. So again, this idea of a control plane, a single place. You can go to the Loadmaster and load a template, obviously. But wouldn't it be nice if you didn't have to know the password and credentials for every single ADC in your environment? We also then have firmware management. Again, today this is going to be KEMP only. There are licensing and proprietary issues for me being able to say I can push an F5 patch to an F5. Maybe those will get worked out in time, maybe they won't. And again, here was this idea of backup. So why don't I go ahead and back up all of the devices I'm allowed to. And so now the toasters will come up and tell me, I've talked to that device, I've asked it for a backup, I've gotten the backup, and I've put it over into the repository for you. So again, control plane. And then finally, licenses. So what is the status of my licenses? Again, this is going to be KEMP information today. There are proprietary issues around displaying other people's licensing information. We hope that someday that will go away as well. But that's the repository component of configuration. If I now go down to a device, you can see some new information came along. And one of the very first things I fought for when I saw KEMP 360 is that button right there. Basically, I have in my TPM environment about 150 load masters. Remembering IP addresses and DNS names and subnets just got to be incredibly difficult. So what we did is in the configuration, I've lost my mouse. In the configuration of a device, we have added the mechanism for attachment to that device or connection to that device. And so now, given that I have actually filled this in for this device, This is optional information. I can now use the Open WUI button under System Configuration and actually, no, I didn't bring my keychain, thank you, and actually connect to that device. So again, just an act of convenience, but one of the most popular features of that piece of KEMP 360 Central. Other things I can do, remember I told you we poll. And what we have found is, again, let's go back to your question about technical deficit. We could make you run KEMP 360 on an 8-core 32 gig machine. And then we'd have the ability to poll 1,000 load masters every second. We didn't want to do that. So we broke polling into two components. Statistics, which are very important to us because the graphs are real time, which we poll every 5 seconds. But configuration changes, we only poll once an hour. But we've added a feature to say, well, look, I think some changes have happened to this device, so please force poll it for me. So that's really the other main component of what we do under this piece of 360 technology. Remember I said there would be one aspirational slide? Well, this is it. So what you've seen is this so far. And what you didn't know that you had seen was repository management and licensing management. Those were kind of just features that were bundled in, but those are actually externalized components. Kurt is going to do a brilliant demonstration for you of 360 Vision shortly. And I'm going to talk about this component, which is our automation. But this is what the customer cares about. These are the platforms, these are his ADCs, and these are his applications. So you can see what we're trying to do is get our human to have only one place he needs to go. So he doesn't need to have a login on ALTSI, he doesn't need to have a login on KEMP 360 Central, he doesn't need to have a login on the deployment SaaS. He can come here and everything that he wants to do to this can be done from here via his own capability or by taking in information. Again, I'm not going to steal Kurt's thunder, but this link here is new, and it's going to become incredibly important. This is going to do amazing things. Again, I don't want to infringe, but it's going to do amazing things on proactive monitoring. This is going to say, hey, you've got the wrong persistence option set on this VS, but I can't do anything about it. However, I'm willing to tell the guy that can do something about it that you have the wrong persistence option set on this VS, and he can then give you the option to say, tick here and I'll fix this for you. So proactive, and now combining the two together. This is never going to be AI, this is going to be major AI. Okay? So that's the futures slide, the only one.